All right, let's start looking through these. So our first question here is asking us to evaluate 3x plus 4 at two different locations. So we're going to look here at when x equals 2. What are we going to do to evaluate our 3x plus 4 where x equals 2? What do we do? Put 2 in for x. This is substitution is what this is. So I'm going to take the fact that x equals 2, and we're going to take 3 times 2. We're substituting it in place, plus 4. So what is 3 times 2 plus 4? I heard it. It was very quiet, but it was there. Say it louder. 10. Because 3 times 2 is 6, plus 4 gives me 10. So when we're given a value like this, what we're doing is we're substituting it in. Same vibe down here. We're evaluating the same statement, but this time at x equals negative 3. So I'm going to take my 3 times negative 3 plus 4. And what are we going to get here? Because 3 times negative 3 gives me negative 9. Negative 9 plus 4 is negative 5. So we're just substituting those values in, putting them inside and finishing solving. I think that might be relevant to what we're doing today. All right. Our second one is going through our solving systems, what we did yesterday. So we're graphing both of these lines. So on this first one, where does my first point go? Where do I start? At 3. My y-intercept is happening at 3. And how do I move? What's my next point? Down 1, right 2. Down 1, right 2. Down 1, right 2. Or I could go up 1, left 1. As long as I flip one arrow, we're headed in the right direction. Negative slopes should always look like they're falling downhill. Always makes kind of a slide. Now let's do our second one. Where am I going to start here? Negative 4. And how do I find my next point? Up 3, right 1. Up 3, right 1. Up 3, right 1. I could go down 3, left 1, flipping both if I wanted to, but we don't have enough space that way either, so don't need to. So, where is our solution? 2, 2. It's that guy right there. Solution is at the point 2, 2. Listen. Questions on either of these? Because we're going to still be working with systems today. We're going to work with pairs of equations. But we're going to kind of take this and smash it together with this. Because we're going to solve things algebraically, meaning we're not going to be graphing things. So we have a couple of options when we start solving things algebraically, and I'm going to show you one of them today. I'm going to show you one of them tomorrow. And we'll go from there. So our first option when we are evaluating systems of equations is using something called substitution. So y'all gonna have to get your notes out for this. I did not make more practice. I know, I'm horribly forgetful. What's that?
When I tell you that the advanced players got invited to this, I can't remember correctly, it's called Castlewood Singers Invitational or something like that.
Nice.
And we're singing Waving Through a Window from Dale.
Ooh, good song. Oh, what time is it? I am said that Waving Through the Window is like the breakout song from that show, I thought for sure that which song is like his big presentation song, You Will Be Found, would have been your generation's Seasons of Love. It should have been. It should have been your guys' generation's Season of Love.
I keep thinking Seasons of Love is from Dear Evan Hansen for some reason, even though it's from Ryan.
Child, it hurt my heart.
I don't know why, my brain just thinks that.
I know, they're both probably similar in age to your brain.
The Cetaphil, the CeraVe.
Not the lotion, but the ones in the jar.
If you head towards the cafeteria and then go down to the right, to the left.
Except for this
Yeah, no, I definitely thought You Will Be Found was going to be your generation's Season of Love. It should have been, and that should have been what they did at the Tonys. Instead of Waving Through the Window, like, I could rant about how the producers dropped the ball with Dear Evan Hansen and making it your generation's, like, defining musical. Because it should have been. It's a good show. He's a terrible person, but it's a good show.
I haven't seen it, but
I haven't either, but plot-wise, he's still a bad guy.
I haven't seen the plot either. I only listen to the music.
He's a manipulative narcissist, basically.
But it doesn't even remember he thinks he's doing.
No, he's just intentionally manipulating the other family because he got caught in an attempt. This other person that he didn't actually know succeeded in their attempt. And he just kind of glommed on that and said, oh yeah, he was my best friend that y'all just didn't know about. Because he had a crush on his sister. Yeah, no, it's like the drama of the show is insane. But tangent aside, let's get back to substitution. The drama of Broadway musicals. It's fun times.
I know, right?
I can rant about theater for hours. Just saying. I don't know how most sports work, but theater, hours. Okay, so we're going to work with substitution today. And what substitution is when we have one equation. So when one equation is solved for one variable for example, if it's like x equals blank or y equals blank. That's what I mean by solve for one variable. X equals or y equals or a equals or b equals or whatever letter. Then we can substitute, or substitute if we like our emphasis on the right syllable, it into the other equation. Which I know feels like super awkward to say, but it's one of those things that if we're going to take the thing and put it in the other thing, it's really hard to get the right number of nouns to make that make sense in the sentence. We're going to put the thing in the other thing. And so really this works well when we have an x equals or a y equals, or when we could make one of them be an x equals or a y equals, without it being too gross. So we're going to practice this several times today. We are still looking for that point of intersection. So just like we had in the bell work where I found my ordered pair where they cross, we're still going to need to find our ordered pair where they cross. So I need to find x and y. But it's just going to take us a couple of steps to do so. So our first system that we're going to look at here, we've got y equals 2x minus 5 and x plus y equals 7. So when we said we were looking for an equation that solved for one variable, I have here that y equals 2x minus 5. I know this. It is solved for y. If we knew that y equaled 2, just like we saw in the bell work, we could substitute that in place of the y here. Well, I don't know y equals 2, but I know y equals 2x minus 5. So what we're going to do is we're going to take this whole chunk and substitute it in place of the y. So when we're substituting, I'm going to take this and I'm going to make this x plus, and I'm going to substitute this whole chunk in for y. And I'm going to put them in parentheses. 2x minus 5. It's a good habit to be in. It helps when it comes to order of operations stuff later on. Like this. So I'm taking my y equation. Y equals this guy, so I'm going to take this guy and put it in place of the y right here. So we're substituting it in right here. That's what I wrote over there. Okay, then so it's a little awkward, but we're going to use this a gazillion times here. Okay. Are these parentheses actually doing anything for me in this step? Do we need to do anything to get rid of them? Not really. If I had like 2y, we would need to distribute. If we had a minus, we would need to distribute. So it's a good habit to substitute it in parentheses just in case of other functions. But in this one, we don't really have anything, so I can just drop them. There's nothing being multiplied or any subtraction signs I need to distribute through. So this is the same thing as x plus 2x minus 5 equals 7. What can I do now to try and solve this? Yeah. Combine my x's. I've got x plus 2x, so I'm going to have 3x minus 5 equals 7. I heard you had an idea over here what we're going to do next. Add 5 to both sides. I want to get that x all by itself, so let's add 5. So we're going to have 3x equals 12. 7 plus 5 gives us 12. What do I do to find out what x is? Divide everybody by 3. Just by 3. So we're going to get that x equals what? 4. So x equals 4 is great and super helpful information and part of our solution. But only part. We still need our ordered pair, our point where they cross. So we need to find y. You can use either equation to find y. We've got a y equals equation. We can use that. I know that y is going to equal 2 times my x, but now I know my x is 4 minus 5. What does 2 times 4 minus 5 equal? Yeah, 2 times 4 is 8, minus 5 gives us 3. So our solution is our ordered pair, x comma y. So in this case, it's going to be 4 comma 3. So it has more writing, but it's actually less work than graphing everything. Because if we had to graph it, we'd have to solve our intercept form, we'd have to find our graphs, we'd have to get a ruler, it's a whole lot more stuff. Questions on this first one? Okay. So when we're handed one that has a y equals, that's super duper handy. We are not always handed one with a y equals. And honestly, at this point, we don't have any other way of doing this. We could graph them, but that top one's going to be a beast to graph. But I can manipulate things if I want to. So if we are not given an x equals or a y equals, let's see if we find one that has a letter with no number outside. I've got an 8x, a minus 3y, an x, and a 2y. if we look at this x, I could solve this for x. Could I get this to be an x equals? What would I need to do to make this be x equals? Yeah, if I subtract 2y from both sides, we have our x equals, and you can put it as minus 2y minus 12 or negative 12 minus 2y. It genuinely does not matter. Thank you, screen. I'm going to put it the minus 2y minus 12 just because I like to have my letters in front. Hey. Thank you. It's all good. It goes with the tiniest gust to slam. So now what we're going to do is I'm going to use the fact that x equals this to sub it into my other equation. So we're going to substitute it in to this guy. So it's going to go in place of this x right here. So I'm going to take this, and we're going to take our 8 times x, but instead of x, I'm going to put in my minus 2y minus 12 in place of that whole x. Those are awfully close together color-wise. Make that blue darker. Minus 3y equals negative 1. There we go. Okay, now they look like different colors. You want to see where all those pieces came from? Whenever I substitute in, I always put it inside parentheses here because it really helps us when we get to this next step. Because what do I need to do first in order to get rid of my parentheses? I need to distribute this 8 to both pieces here. So we're going to have minus 16y minus, what is 8 times 12? Yeah, calculators. Use them. 96. Then we have our minus 3y equals negative 1. So we're going to distribute all of our information through. And now we're ready to solve this for y. What are we going to do first? Or what do you want to do first? We have lots of options here. Combine our like terms. I've got minus 16y and minus 3y. So that's going to give us minus 19y minus 96 equals negative 1. Any left? Huh? Oh, okay. Awesome. Glad I showed it.
We can add 96.
Add 96 to both sides. Plus 96. So now I have negative 19y equals positive 95. What do we do next? What can we do next to solve for y? I'm going to divide both sides by negative 19. That lets me get that y all by itself. So our y equals negative 5. Use your calculators for those calculations, guys. Right? That is 100% valid. Utilizing tools. So we still need to find our x value. We need to have our full ordered pair. So what we can do is we can use any of these equations to find our y or our x value. I could use this one if I wanted to. I could use this one if I wanted to. But since I have an x equals, I might as well use this one. We can use whichever one we want. You can genuinely, it does not matter. That should all be the same. So I'm going to do my x equals minus 2 times my y, and now I know my y is negative 5, minus 12. What is negative 2 times negative 5?
10.
Positive 10. Positive 10 minus 12? Negative 2. When in doubt, type it in the calculator. 100% valid. So our solution, how are we going to write our solution? -2, -5. It does not matter what order in which we solve them. It matters that it's x comma y. Just a sec. I have a lot of people that do it. Well, I solve for y first, so y goes in front. No. X comma y every single time. Questions on this one? Okay. So we're going to do this one next. It's got a decimal. That's okay. We can do this. We can do this. We even are given a y equals equation here. So we've got our minus 5x plus 2.5y equals negative 15. And I've got my y equals 2x minus 11. If you are one of those people that absolutely, completely, and totally hates decimals, you can multiply to get rid of it. If you multiply everything by 2, negative 10x plus 5y equals negative 30, valid. You can multiply everything by 10 to get rid of that decimal. As long as you hit that whole equation, both sides, you can do that. I'm just going to plow through with the decimals. They don't last super long. So we have a standard form equation, and we have a slope-intercept form equation. So what I'm going to do is I'm going to use the fact that I know that y equals this guy here to substitute it in place of this y right here. So I'm going to take my minus 5x plus 2.5 times my y. So I'm going to put my whole statement for y inside parentheses. 2x minus 11. Oh, someone had an idea. Equals negative 15. So we start by substituting in exactly as it is right there. What should we do next? Distribute. Absolutely right. So I need to distribute this to both pieces here. So I have my minus 5x plus 2.5 times 2 gives me 5x. 2.5 times 11. Ew. But we can do that. It's 27.5. Just type it in the calculator. And we're still equaling negative 15.
Would it the 5s cancel out each other?
Yeah. So when we start with our combining like terms, I have 5x and minus 5x. How many x's do we have left over? 0 x's. These guys cancel out. So what we have here is negative 27.5 equals negative 15. Ooh. Does negative 27.5 equal negative 15?
No.
I knew. Definitely not. So this is a falsehood. This is a mathematical lie. This does not work. This is false. There is no case in the entire existence of the universe where those two things equal each other. So what might our solution be? No solution. These are two parallel lines. If we wound up with something like this, where my x is canceled out, and we got something that is always true. 2 equals 2. 7 equals 7. 0 equals 0. that's when we would have our infinitely many solutions because it's literally the same line. So if we get a falsehood like this, it's no solution. If we get a truth, then it's infinite solutions. If we get a number, it's a point. I'm just curious to see what that looked like when we do these algebraically. We'll see them pop up every now and then. One more. Just one.
Ew, word problem.
Don't make me start my coffee. That would hurt. To be fair, it is 3 sentences, technically 2, because the last one almost doesn't count. The sum of 2 numbers is 11, and the difference of those 2 numbers is 1. We're going to find those 2 numbers. So if I have 2 numbers, how can I represent that the sum of 2 random numbers is 11? Do we know what either of those 2 numbers are? No. So if I don't know what they are, pick a variable, x and y, a and b, h and k, happy face and heart. I genuinely do not care what your variable is. I don't do it with emojis because my drawing is so good. I did it once and it was such a distraction. Just saying. I tried to do thumbs up and it wound up looking like a mitten by the end. It was bad. It was bad. All right, so our 2 numbers, first ones I heard, we're going to use x and y. So when it says the sum of those numbers, what does sum mean? Add. Sum means to plus. So we're going to have x plus y equals 11. Then we're going to have the difference of those 2 numbers is 1. How do I take the difference? X minus y equals 1. And we have a lot of options on what we can do to start solving this. What one do you want to solve for a variable? It genuinely does not matter. You can take the blue one and solve it for either x or y. It'll be exactly equally difficult. You could take the green one and solve it for x with the exact same amount of difficulty. Y would take us 2 steps to solve it. So if we genuinely do not care, I'm going to solve this one for x just because I like to get rid of that minus sign. Then we won't have to distribute. So if I solve this for x and get this as an x equals, what are we going to have?
Negative. Positive y.
Positive y plus 1. Because we're going to add y to both sides. Now I can use my substitution. I know my x equals this piece. So we can substitute that in over here. So we're going to have my y plus 1 plus y equals 11. See that? Where those pieces come from? What's up? You whining about the temperature again? Okay. I thought you were saying it was cold. I'm like, no, it's really not. All right, what can I do here to solve this one?
First of all, get rid of the parentheses.
Get rid of those parentheses. They're not doing anything for me. Y plus 1 plus y equals 11.
And then you can add the y's together to make 2y.
I have 2 y's plus 1 equals 11.
Subtract 1.
Subtract 1 from both sides. 2y equals 10. So what does y equal?
5.
5. Divide both sides by 2. So if y equals 5, what does x equal?
6.
6. You can use any of the equations. You can use our x equals y plus 1, probably the shortest one. Or you can go what plus 5 equals 11. or what minus 5 equals 1. It genuinely does not matter which equation you use. I'm just going to write it out up here. So my x equals 5 plus 1. So my x equals 6. So my pair of numbers is 6 and 5. Those are our two numbers that have a sum of 11 and a difference of 1. We could absolutely write this as an ordered pair. Since we picked our variables, it actually doesn't really matter. But since we picked x and y, we absolutely can do this as an ordered pair, 6, 5. Because they don't tell us what variable it is, so we could have switched them. We could use A and B. We could use Texas and Hart.
You could have also just subtracted 5 from 11.
Absolutely true.
And just
There's a lot of ways to go through it. I just wasn't going to do all 4 ways on the screen.
there's 4 ways.
At least.
Brain
So there's choices. The way you go through one of these problems might not be the same exact steps that I take. We did not have to pick the green one to solve for x. I could have solved the blue one for x. I could have solved the blue one for y.
This makes no sense.
What?
It's not actually brain.
It is not. I missed the red. To be fair, it I believe came from a like $5 Amazon box. Or that one may have come from Wish.
And also the one blue.
Yep.
Makes no sense.
All right. I know I just gave you homework yesterday. I'm gonna give you another one.
Oh, yeah.
I know. So, but this one, we do not know enough to do everything on it right now. We can do the top 3 is what we did today. The bottom 3 are what we're going to do tomorrow. And on the back side, we have these story problems. One of them is very much like one we just did. Very much. Okay, and then you guys have almost 10 minutes.
To be honest, at this point, you could probably just record one of those videos. It's like, things my students says just from my confidence. At this point.
I don't keep track enough of the chaos that I'll say to do one of those series. I also don't really want to do this for the channel. Like I could, but then there's a whole lot of pressure on.
And also you have to edit and edit.
I don't want to do that.
I don't.
My only videos that have ever like had any traction online have been book reviews where I do not show my face. It's just the title of the book and text. And a video my husband took, which went moderately viral. Like I think we're at 250,000 views right now. It was a porta potty that was on a crane, and I put the Doctor Who theme behind it. It was a porta potty just like spinning, hanging from a crane. It was fantastic.